Okay, I am going to start here. I have someone here on the background just checking for me. Like I said, load shedding, services, COVID. This is Africa. Blame it on anything you want to, but I just have someone to check for me if everything is going according to plan. If you have any issues, guys, please pop me a question in the question bar. And when I see something, I will look into it and I will get back to you on your questions. Okay, so first of all, the agenda for today, we are quickly going to recap Industry 4.0. There are some people that are new to this webinar series of ours, so I just quickly want to say what are we wanting to achieve and what is our plan with you guys in your company, basically. So then we will discuss why simulate. We will do simulation in Inventor. Then we will look at Autodesk Inventor Nastran. We will then do a little bit of design data management with Vault, and we will have a closing and the questions thereafter. Okay, so for now, please people share our pages. Please comment wherever you can, Facebook, LinkedIn. Go and like all of our pages, even YouTube. You can go and like, you can subscribe to our YouTube channel, and then you are able to get all of the videos that we've done from the past up to now, and you can re-watch anything that you would like to re-watch as well. Okay, so I'm Melanie Burger, the Manufacturing and Process Plant Specialist. I have a mechanical engineering diploma. I have over 10 years experience in the drawing office as a supervisor. I'm very passionate about data management as well as training, and I'm an amateur bass and drums player. First of all, I would like you to have a say. So I'm going to launch a poll for us, and please tell me, how familiar are you with Baker Bains and what we offer? I'm going to give you a few seconds, and you can either say very familiar, somewhat familiar, not familiar at all. Did you get the poll? Not yet. Okay. So only 20% of the people voted. Please note that we cannot contact you if you should indicate so. So this is just to see how many of our customer base actually do know what we are doing, if we can represent maybe a little bit more or discuss anything else with you. So if you would like us to contact you, we will ask you at the end of this to just in a chat box tell me if you want us to get in contact and to discuss a little bit more around this topic. Okay, 5 more seconds. Let's go. So I'm going to close the poll. 50% said that they know they are somewhat familiar, and 50% said not familiar at all. So welcome very much to this webinar today. I hope you enjoy it and that you will join me again next year. So Baker Bains has evolved over the past 6 years from being an Autodesk reseller to a consulting company. And we like to solve our customers' problems, like you guys. We like to solve your customer or your problems through our digital transformation to help you to design and make a better world. In doing so, we offer various business process improvement, consulting services, survey and design hardware and consulting, design software consulting, and we top it off with a blended learning approach to how we believe that you as our customer can or should digest your information. Once we know you a lot better, we are able to help you, train you, and assist you a lot better. So first of all, the fourth industrial revolution. So what is the fourth industrial revolution? To explain that, I need to start from the beginning. So before the first industrial revolution, most of the industrial work was done manually or aided with animals. The first revolution was started in the 18th century. During this, manual tasks were replaced by the use of steam engines and other machines. Agriculture and textile industries are the ones that benefited most from the first industrial revolution. The second industrial revolution was started with the use of steel and electricity inside factories. It started at the end of the 19th century and the early days of the 20th century. During this era, factories were electrified. As a result, productivity increased and mass manufacturing concepts also came into the picture. Development of railway networks also enabled the transportation of goods from one place to another and a lot faster. The third revolution was started in the mid of the 20th century. Most of our today factories are the result of the third industrial revolution. During this time, manufacturers started to incorporate electronics, digital technology, and automation inside the factory. Now, we are living in the era of the fourth industrial revolution, or Industry 4.0 as we call it. In advanced factories, automated machines and robots are aiding human workforce to do manufacturing activities. But this is just a start. Industry 4.0 will take manufacturing to a new level by introducing the concept of smart factories. So, producing smart products using flexible mass manufacturing technologies inside smart, fully automated factories. Machines will operate independently on their own with just a little bit of guidance from the human species. So how are we going to help you to get to Industry 4.0? Well, we've identified these steps that you see on your screen. We are running a campaign and walking you through the steps that you need to get to Industry 4.0. So we had an event in the beginning of this year where we did discuss the whole design and the Industry 4.0 and how we are going to get there. And we started off with 2D to 3D design. That really made an impact on most of our customers. They were all excited. They started contacting us and we started helping them to get their 2D designs into a 3D format to be able to go over to design automation. So now that they are in design automation phase and we've helped them to get there, we are trying to get them from not only automating their designs, but moving it over to the simulation phase. So I also want to stress the importance, as you can see on the screen there at the bottom, your data management. It is very, very crucial. Now, in our area, the manufacturing area, or the process plant area, we have Vault as our basic data management system. And it works with Inventor so well. It works with AutoCAD Electrical, everything, all the software that you can think of, you can use within Vault. You can automate your life cycles, you can have job cards or engineering change orders, as we call it, and then you can automate that whole system without having manual signatures or anything like that. And today we will look a little bit at those life cycles. So the next poll I'm going to share with you is the one that says, are you ready to start for designing Industry 4.0? So that means, let me just go back one slide. That means, are your designs in 2D to, did you change your designs from 2D to 3D? Did you start automating your designs? Are you happy and comfortable with simulation? Do you know what generative design is? If not, you cannot move over to the Industry 4.0. Those are the basics that you need to get in place. So, poll question again. Are you ready to start designing for Industry 4.0? We would just like to see, once again, how many of our clients actually know what Industry 4.0 is and where we can assist them in getting them up and running. It looks like one person knows what Industry 4.0 is. Just gonna wait for a few more responses. Hi guys, I know you are tired. End of the year, enthusiasm has went down the drain basically. But let's try to make next year a better one for you by helping you. Okay, so I'm going to close this poll. Thank you for your responses. It is very interesting. All right, so product design challenges that you may get and where simulation will help you. So, are you facing these challenges? Do you need to make accurate design decisions without building multiple physical prototypes? Are you seeking confidence in simulation results before investing resources and designs and changes or on any of your new products? Product design actually includes a wide range of materials, not just common metals. Motion and the combination of multiple physical effects are critical design considerations. Product design teams need to perform simulation on geometry from multiple CAD software tools. Avoid field failures before it happens. You can determine durability of structures under repeated loading. You need to optimize the design and manufacture of models to meet the demands of an increasingly competitive global market. Manufacturing firms face intense pressure to constantly innovate, reduce development cycles and time to market, and avoid in-field failures while staying profitable. There are powerful benefits that a CAD embedded FEA technology can bring to your product development process. Advanced analysis empowers engineers to subject their design to real-world behavior and optimize product quality for performance before manufacturing. This translates into innovation, better quality, lower costs, and minimal field failure. At its core, manufacturing simulation is an inexpensive, risk-free way to test anything from simple revisions to complete redesigns. Sorry guys, I heard that there's something wrong with the view. I'm not sure what you guys can see at the moment. Oh, that doesn't show my screen again. Yes. All right, let me quickly see what's happening. Sorry for that. The polls are not supposed to. Is that fine? Yes. Cool. Sorry guys, they're not supposed to close my presentation. But yeah, that's the joys of working in Africa now. Okay, so they just asked me to show you this one again, why we simulate. It is to meet the demands of the industry, where we can have quicker, better products without taking some of our profitability away. So these are some of the challenges that occurs that you are facing as a client of ours and in the industry, and where analysis like the FEA analysis can assist you. Okay, so like I said, at its core, simulation is an inexpensive, risk-free way to test anything from simple revisions to complete redesigns, always with the purpose of meeting production goals at the lowest possible price or cost. So, to reduce physical prototyping, you can know early on which design is better. You can reduce your prototyping cost, test stand costs, and overall time required for the tests. And you can do it the first time right. You can foster innovation. You can check the feasibility of the novel approach, evaluate out-of-the-box product applications before you implement them, explore more design options before you can just run off with the first idea that came along, and support data-driven decision-making. So it's going to give you a lot of information that you can have and do to make sure that you make the the best decision before even creating the model or the part that you are trying to do. So continuous improvement also comes along. It brings the design and simulation specialists closer together. So now your design as well as your specialist people are working closer together, looking at the results together, trying to figure out how are we going to make this a lot better for us as a team, more profitable, for instance. That's what everyone is looking for. And they work together to get the best solution. It reduces the risk of failure and it secures liability. It increases your product knowledge and improves quality of the performance of your product. So we're going to look at simulation in Inventor. We have a video here of analyzing assemblies. I just quickly want to do something here. What did I do wrong now? Hi guys, today is not my day. I'm just quickly trying to move you out of my way and get this sound off. It's the wrong one. I'm really very sorry about that. Truly fitting into where we are. Right, I'm quickly going to switch off the sound, make sure that it is off, and then we will get you going again. All right, so let's get back to business. Right, so simulation in Inventor. Oh, no, it's not working. Guys, I'll get back on to you with that one at the end. I know what went wrong, but I'll fix it now. All right, so Autodesk Inventor Nastran. Now that is actually what we tried to get to. We did the Inventor series, I think a month or two ago. We talked about the Nastran, not Nastran, the Inventor ways of doing your simulation. And it is very similar to what you can do in Nastran. Now, in the past, you used to get Nastran as part of the Inventor package, but now it is a standalone. So in your PDM collection, you will have Inventor and you will have Nastran that you can download. You will have two products at the end of the day. And the Nastran will have some more capabilities that you cannot get within Inventor. But let's look at that. So now, the design of machines and products are very crucial here. So machines and products are designed for a specific reason. Like you can see on the screen there, it's some small little pictures of some machines that I came across, even some personal machines like a trainer. You design those for a specific reason. Either you want to get fit, or you want to build something, or you need to lift something, or you need to excavate something. They interact with the physical world. So they must be built to endure a wide range of physical conditions, such as varying temperatures, drops from a height, or even repetitive machining tools. Those you want to eliminate when doing designs. So here are some typical challenges that you will get that come with the design and which often require engineering judgment regarding the object's size, material, and design. So you need to take into consideration if you have any of these challenges, which are complex assemblies with modular designs, variety of operational loads, or a combination of loads, moving parts with a wide range of motion, combinations of materials, and then loads during shipping and transportation or within an assembly. These challenges can be superimposed by uncertainties with the final application or temporary application, which is not covered by the intended specifications. The latter often happens when the product specifications needs to be extended or with retrofits. So the common causes that you will get is asymmetric comprehensive loads or unstable loading, overuse or overloading, heavy vibration from motors or actuators, extreme temperatures or temperature change, inadequate design for the intended application, or loads from contact and motion leading to failure at joints. So the impact of simulation can ultimately become visible in various business areas, as you can see on the screen, some of which may be directly connected, such as your brand's reputation by afflicting from product recalls or machine failures, or vice versa. Your company being known for well-engineered, clever products. Others are more subtle. For instance, falling back in innovation speed or missing out on substantial innovation options because the costs for prototyping are too high, or there is no time to do an excessive hand calculation for a second design variant. So there are different ways to verify if a design performs as intended. They range from applying prior experience to outsourcing simulations and building prototypes. Most of them are associated with a couple of drawbacks. Setting up manual calculations or spreadsheets are very time consuming. I think we can all attest to that. And it often forces your engineers to considerably simplify the real physical situation. Outsourcing and physical prototyping can be convenient, but both come at a quite significant cost of money and time. Once again, I think we can all relate to that. I mean, the previous company that we worked at, there were constantly time issues because we were waiting for a manufacturer. We are waiting for someone to build a prototype. We are waiting for someone to tell us what to do next. And with that comes the money, because everyone either is sitting and waiting for what you're supposed to bring to them, and or your client doesn't get the product in time. And then what do? They don't pay you the full amount because you were supposed to deliver at a certain time. So that also happens. Now, finite element simulations has become an established method in engineering, but most analyses are limited to linear static simulations. For some materials, you can take the example of plastics. This can lead to oversimplification, or they cannot reflect repetitive loading when it comes to fatigue. So we're going to look at what is finite element analysis for those that doesn't know yet, FEA for short. So Autodesk Inventor Nastran, a CAD embedded finite element analysis tool powered by the Autodesk Nastran solver, offers a wide range of simulations spanning across multiple analysis types, such as linear and non-linear stress. It even does dynamics and heat transfer. It provides a consistent user experience and eliminates the need for multiple single platform simulation technologies. Inventor Nastran delivers high-end simulation technology in an affordable subscription to the PDM collection. For those who don't know PDM, it's the Product Design and Manufacturing Collection, in which you get Inventor and Nastran, for example. Now, the advantages of this is that Autodesk Nastran solver technology are inside your PDM collection. So analysis for composite, nonlinear, dynamic, and more can be done in one go. It's accurate verification and documentation you can do by using NAFEMS, which you will find within the Nastran program. It's integrated. It's embedded in the Autodesk Inventor. It supports Autodesk Vault. It's a major plus for most of the companies. The geometric associativity and different model states are a huge integrational advantage as well. And it supports multiple CAD products via Inventor. So we are going to look at some basic analysis capabilities. You get the linear static analysis. Linear static is one of the most common types of analysis. It determines stress, strain, and deformation resulting from applied static loads and imposed constraints. So linear stress, strain deflection, inertial relief, thermal stress and deflection, press stress, mass properties, multi-axial fatigue are all part of this basic analysis type. The next one that you can get is buckling. So buckling assesses stability under loads. It examines structures for sudden failure modes caused by comprehensive forces, critical loads, and mode shapes, linear and non-linear initial stresses, pre-stress, static, and or normal modes. Enables engineers to analyze structures subjected to initial stress and model the effect of the initial stress state on the structure's displacement, stresses, and modes. Also, pre-stress static and normal modes determine the undamped natural mode shapes and frequencies of structures, allowing designers to explore and resolve problems with noise and vibration, natural frequencies and mode shapes, flexible and rigid body motions, model participation factors, effective mass or weight, and reaction forces, linear and non-linear pre-stresses, or you can call that stiffening, and virtual fluid mass. You get the linear steady state heat transfer. I'm just going to carry on a little bit. Using the principles of conduction and convection heat transfer, engineers can examine designs for equilibrium temperature distribution, conduction, convection, and radiation. Composites provide easy, straightforward handling of complex ply data. And like a PUG and an LIR-CO2 means reliable and insightful results, linear and non-linear, conduction, convection, and radiation. I just want to carry on to the next one in the meantime. Okay, there is some sort of a miscommunication here as well. So yeah, you also get advanced nonlinear materials. This solver captures complex nonlinear phenomena such as plasticity, hyperelasticity, and shape memory effects. This enables analysis to model a wide range of materials, from metals and shape memory alloys to rubber and soft tissues. So Inventor Nastran. I'm going to discuss quickly with you or show you a video after discussing this with you about Inventor Nastran and how it looks and feels. Now, once again, this example you will find in 2020, 2021, and most of our customers are still on that programs. Therefore, this video. If you started on 2022, then it will look exactly the same, but you will just open it through Nastran and not through the environments and then going to Nastran. So with simulation capabilities, you can quickly validate the design ideas and improve the product performance. You can do proper validation processes with quick feedback to your design team and also see what is the downstream tensions. You can understand the downstream impact in production and service and look at how it reduces the amount of fire drills in, for instance, an organization. And some other examples is like linear stress, thermal stress, and fatigue. All of that can be used when looking at these types of analysis.
Inventor Nastran. To access Inventor Nastran, click the Environments tab and select the Autodesk Inventor Nastran button. In Canvas, simulation tools provide a wide range of simulation types, including statics, dynamics, nonlinear, composites, and heat transfer. Advanced meshing technology means greater accuracy for your geometrically complex models. Faster and more robust automated contact generation provides better accuracy for assemblies. Highly accurate nonlinear and dynamic capabilities and advanced material models means results you can rely on to make more informed design decisions. Inventor Nastran provides a comprehensive selection of material models. Examples include isotropic materials, including plasticity, orthotropic materials, and other advanced material types ranging from shape memory alloys to rubber. You Because of the in-canvas integration with Inventor, you can make changes to the geometry model and have them automatically propagate to the finite element model, saving you time and eliminating rework. Inventor Nastran provides a powerful and convenient toolset for studying the effects of design modifications and exploring design content.
Okay, so that's basically how it looks and feels. And it looks exactly like the normal Inventor environment that you are used to. And it does look exactly the same in the Nastran program if you download it separately. So we're going to have a very quick look at a customer case study. Now, earth-moving machinery cabins need to withstand the vertical impact of a test object, weighing about 300 kilograms at 27 kilometers an hour. This is highly dynamic impact, and using Inventor Nastran's explicit solver, we can compute if our design can take the impact of the load. And there you will see what Nastran did for us. This is the study to indicate what is going to happen. And there you can see. Okay, so no issues. Now you know you can actually carry on with your design and or build this without experiencing any problems. So some practical examples for Nastran, some other examples that you have in just not FEA is on the left, you will see the cool down. It's the cool down of a casted part after it was taken out of the mold, and how long until its core temperature is below a certain temperature. That is what Nastran can solve for you. In the middle, you will see that we have sealing, hyperelastic large deformation contact. So the door or window sealing being compressed, does it seal right? Are the stresses too high for the sealing material? Let's quickly play that and see. So that is basically what it would look like when you get the study done by Nastran. And you can see from blue, it turns a little bit lighter blue, almost to a greenish, but it's still acceptable. So you can take that. So on the right, we have the punch drawing. So in a punch drawing, you can find out how much force to deform the blank, what is the maximum or the plastic stress within the final part, and will it rip during the deformation process? And let's look at that. And it gives you a nice graph also to show you where it's going, what is happening. And then you can see very nicely, nothing is going into the reds. It will work, but it gives you also, you can see on the side there, it shows you that it moved a little bit from the side. So you can make your plan and design and changes according to what you've seen on the screen. So on this one, on the left-hand side, we have a nonlinear bucket explicit solver. So you can ask here, how much load can it take before it buckles? And where should we add reinforcement structures? So now you will see where it is going to buckle and how to strengthen it all. On the right, you have a projectile penetration. In this case, you can ask, how many layers will be penetrated? And what are the impact forces? You will see where the red is, the yellow, the green, and it is still going and going, and the speed. You will be able to analyze all of that before you decide, is this going to be what you need in your product or not? Okay, so next up quickly, we're going to look at life cycles within Volt. So just a quick overview. You'll be available within Volt or work group and professional to do a life cycle stages. It gives the control to revise and release the data. The lifecycle states can be set within Volt client or the Volt add-in, as you see on the screen. Those are the panels and the ribbons that might be used. So some lifecycle definitions that you have, you use different states to control different files. For example, work in progress, released, obsolete. You can set that up however your company works. You can decide what needs to be done. So it's customized to suit your company's structure and processes. So there's 6 default lifecycle processes. The 7th becomes available when using in terms within Vault Professional. So you can opt out of lifecycles if you don't want to use it by just clicking on the None button, and it won't select any of your lifecycles. It will still allow you to categorize your behaviors, at least. Sometimes you might not just want to do, a life cycle. You just want to get the drawing somewhere without it being approved by anyone. Then you would use that specific function. So the basic manufacturing release process is you have the work in progress. Then you send it out for review. You send it to released, and you can make it obsolete if it's no longer available. There's a flexible release process, and it's almost identical, but it includes a quick change for a non-form, fit, or function change that do not require a revision change. But I would not suggest you use that specific point. This is also for a quick change, should it be restricted by managers only. The simple release process will be used for various workflows. It only includes work in progress and released states. And a long lead time release process is used for long lead time projects where it will span over years or lots of months and years, and you need to then only get it out of the system. And it's the same process as the flexible release, and it has a pre-release state. It enables data to be sent to production floor for manufacturing, but allows for further changes if any should occur on the manufacturing floor. Long-time release processes with a change order. That's what we used at the previous company, and it works wonders. It's same as the long-time release process. It only appears with Vault Professional, and it adds additional criteria prior to lifecycle transitions with check if a file is under control and give more information about that specific file. The item release process controls item lifecycles. That's for a specific item and not for a specific file. The design representation process, PDF files are automatically assigned to this process. If you wish to, if you do not want to, you do not need the option. It allows administrators to manage rules, life cycles, and properties of PDFs without changing the associated design files. So in summary, life cycles help control the security of your data. It mimics the formal approval process common in the industry, the manual process with signatures and all that jazz, not getting people, being late, all of that. So basically with Vault, when you use a lifecycle stage, I'm quickly going to run through a system with you, setting up the lifecycles and how it works. So to set up your work with lifecycles, you must have administrator privileges. Then from the Tools drop-down, select Administration, Vault Settings, and select the Behaviors tab from the Lifecycles and Revision sections at the top. Click the Lifecycles button. This opens the Lifecycles definition dialog box. Each of these definitions has different settings and controls, which can be found within the Lifecycle Details section at the bottom of the dialog box. The Transition tab contains, it's first the General tab that you will see there. It has a name and the state description. The Transition tab contains a list of file transitions. Bumping a revision or synchronizing properties are a couple of the actions that can be initiated when working with the Transitions tab. The Security tab displays permissions granted to users or groups when the file is in each state. For example, during the file, for review state, you could set certain groups to only have read-only privileges, ensuring that no changes occur while the data is being checked for quality and consistency. Vault Professional adds a checkbox at the bottom of the tab within the associated file section. By enabling this security for associated files of items checkbox, you can have them working independently. You can set the security permissions for any files associated with the item in question. When viewing the control tab, you can see that whether or not the selected state is released or obsolete. In the comments tab, default comments can be added to each stage by clicking Add. This allows the users to select from a predefined list of comments when they want to make a comment. Simply viewing the settings of each state is an excellent method for understanding the requirements, the specifications, the processes, and knowing which process may or may not work in your specific environment or with the specific file. However, if you need to alter one of these definitions or create a new one, there are buttons along the toolbar at the top that enable you to customize these definitions or create a new one. You can open a new definition with the dialog box that displays. You can add a definition name and then select a description. Write the description so that everyone knows what it's about. In the category state, when you click on the drop-down, you will find that you have a lot of different objects that you can choose from. When building it from scratch, you're required to create every state that the file will pass through when doing your life cycles. So down here at the bottom with the plus sign, you can add life cycles. Delete is not there, and select the life cycle. You cannot choose any of those. They are disabled at the moment, but you can add because we do not have anything in our list for the moment. Right, once again, on the other side of our dialog box, we can copy any of our old lifecycle definitions, and we can use that to create a new one. So you will rename in the definitions name. You will choose what categories are you looking for. You can change your description if that's what you want. They can all be updated within one time. Now, if any of the states within the definition are associated with the latest version of any file within the vault, the definition cannot be deleted. If this is not the case, a dialog appears that lists the categories currently assigned to the definition. Right, so let's quickly look again here at, we are currently under review. If we click on under review, we can delete this. And this dialog box is the one that will prohibit you. And it will tell you that if any of the states within a definition are associated with the latest version of any file within the vault, the definition cannot be deleted. Click yes to continue and a warning appears. If you click yes again, the definition will be deleted. If many lifecycle definitions exist, you can expand the filter dropdown to quickly locate the one you require. This filter enables you to narrow the list of definitions based on which categories are assigned. Simply choose the category you wish to filter. Only the definitions with the category assigned are listed in the pane below. Working with lifecycle states and definitions on your files, folders, items, and custom objects enables you and your team to further control the data as it passes through each available stage in its lifetime. By setting the control and security options, you can ensure that Vault objects are not altered at specific stages, such as when they are in review or after they have been released from the engineering department. And that is really a very nice function to have and to use within your company. It really does make your life a lot easier, especially if you combine this with engineering change orders. And an engineering change order is going to give someone my English today. It's going to give them the instruction of what exactly it is that you want, at what time, and who is going to approve it next. So when they are done, they submit their ECO, and the next guy in line will get an email, he needs to approve, and everything goes automatically from the one point to the next. No signatures, no time delays, and no engineers that are cross with the design department because they think they received something or they think they didn't receive something when they actually did. Then you have the proof to show them what to do. And it makes the life of supervisors and management so much easier to have reports and things to draw at the end of the day to say who sat with this information for how long. It really does make a difference. I can talk the whole day about data management and how Vault can make your life better, but for now, we are running out of time. So, in closing, I would like to know, the PDM collection will assist you in doing all the different types of analysis that you need to do. Now, regardless of the PDM collection, if you only want the Inventor, you want Vault, or you want the PDM collection, you can contact us throughout the day at our offices. I'll give you the information in just a little bit, and we can help you to get that product for you. And we will assess your business. So if you are not sure if you are ready for the next step to Industry 4.0, and you are on this webinar, you're not a supervisor, a manager, or anyone that is supposed to make decisions regarding this, go and speak to them. Tell them that we at Baker Baines can come and assess your company. We can see what it is that you do. Where are you in this design phase, and how can we help you to get there? By discussing either training or extra courses, or even like the different programs that you might need to get you there. And then lastly, our staff is trained to work with simulation, and we can help you to get started. We have like a specialist series, for instance, where you can do a course on only FEA. And it may be a half day or a full day course. It's not as expensive. It can be online, which is even cheaper. And we can assist you in getting your simulation going so that you can get to where you want to be and be the best company when it comes to designing whatever product it is that you are creating. So I adopt. That is now our way of helping our clients. So it's a unique consulting methodology where we help our clients. We help you to develop and implement a digital strategy and help you to transform to get you to that best company you want to be. We can help you to optimize your business processes and your workflows, like with Vault, where something can happen automatically and replace the manual, tedious processes. We can help you to adopt your technology. Let's say you do have Vault, but you've never used it before because you're not too sure what is actually going on here. Let's say you do have Nastran, but you never even thought of what does Nastran do. We can help you to adopt that technology and start using it in your everyday life to make your life easier and better for yourself. And we really want to help you to design and make a better world. We want our clients to be at the top of their game. So some of the benefits of this is that we focus on solving your immediate problem, not anyone else's, not the industry's, but your problem. We deliver tangible outcomes, and we have a holistic approach, and we address your organizational issues as they are. Once again, not as how we think they're supposed to be, but as they are, so that we can give you the best support we can. And we go beyond the CAD environment. It is not just CAD. There are some other products that we have that might help you. So when we come to you, we listen to you, we will find out what might be the best approach. It might not be an Autodesk approach. It might be something else, but we can help you to assess and see what it is supposed to be. And this includes the change management. So we will help you to go through that whole process. So for now, I would like you guys, if you have any questions, please quickly add a few questions. I see someone said they are struggling with sound. I hope that didn't stick the whole time after this whole webinar is complete. So once again, what we will do is after this webinar, all of you that joined today, and or even if you just registered to this webinar, you will get a link to the recording. You can go and watch it at your own time. We will make sure that the sound is right and that nothing goes wrong, so that you can enjoy and relax and take in everything that I've said today and make a right decision once again for your company. Any other questions? I'm going to give just another minute or so. You guys know where to go for questions. On the side, you will have a little panel key that will be able to help you view in Windows mode. And one down quickly for me, please. You can raise your hand if you're struggling to type any of the questions. You can send privately or you can send to all. If you have more issues, there's a little arrow at the top. And when you open that up, you will have more options of what you can do. Okay, it works on this side. Okay, guys, thank you so much for attending this webinar. I really do enjoy giving webinars. I know we had a little bit of technical issues. I'm really going to straighten them up for the next webinar in January. And in January, we are going to start with the next phase, which is generative design. And it is going to blow your mind. So please stay tuned. Please come back in January. It's sort of the third Thursday of January, 3-ish. But we will send you an invite. And if you want to invite anyone else, forward that email, tell us, put them on our customer list, and we will get in contact with them. Then you don't need to do the work. Anyway, the way to get in contact with us is as follows. You can get in contact with us online through LinkedIn, Facebook, Twitter, Instagram, YouTube. We like to be in contact with people. We just love people. So you can chat to us on any of those. Go and like all of our pages and thingies, and you will see a lot more from me and my colleagues on YouTube or somewhere on the interwebs, as the guy from Crazy Monkey would say. Baker Bain support runs from Monday to Friday. I do need to make it 10 that we've changed the date of the time to 10 o'clock at night. We are trying to put a little bit more processes and funky stuff in place, so the support people are helping us with that. But from 8 to 10, you can reach us on 011 568 2060 or email our support desk. Then you will have, as soon as the support guys wakes up, they will see your email and they can attend to you immediately. And believe me, they really do want to. They are very good and they do love to work with our customers. So we at Baker Bains solve your problems through digital transformation. And our biggest goal in life is to make you design and make a better world for all of us. Once again, thank you very much. I will see you next year. Merry Christmas, Happy New Year. Bye.